Hi everyone, so today we're going to be taking a look at energy pyramids and food webs. So here we have a food chain, we have grass going and an arrow pointing to the grasshopper and then to the frog and then points to the snake and then finally to the hawk. Now those arrows represent not only where the food is going to go to next, but specifically also where the energy is going to go to. So that's what I mean by the flow of energy, where the energy goes to next. So this grasshopper here has all of this energy, and when the grasshopper eats the grass, that energy goes to the grasshopper. Okay, now the grasshopper has all of this energy, and its energy is going to be transferred to the frog when the frog eats it, and so on. So remember, the arrows point to where the energy is going to go to next. So let's take a look at one of these organisms, the grasshopper. Where is it getting its energy from? We said it's from the grass because the arrow is pointing from the grass to the grasshopper. Now, 90% of the energy that it gets from the grasshopper will use to do its daily activities, things like moving around, growing, developing, reproducing, whatever it needs to do in the day, the grasshopper is going to use the energy that it got from the grass to do these activities. Well, if 90% is being used for these activities, okay, what happens to the rest of the 10%? Okay, well, before we do that, that 90%, when we use that energy that's in our bodies, we actually change it up to heat energy and then we let it out of our bodies. Okay, so this is not just for the grasshopper, this is for all organisms, whether it's a producer or consumer. When organisms use up the energy for their daily activities, they change it to heat and the heat energy disperses, it's let out. Well, what happens to the rest of the energy? So the 10% of the energy that the organism doesn't use, it's going to be kept in the body of the organism. So for the grasshopper, the 10% of that energy is going to be stored in their body, in their fats, in their tissues, and things like that. Same thing that happens to producers too. It's just going to be stored away for later. So taking a look at this, we can put that food chain into an energy pyramid. So if you see, we have the grass at the bottom, then the grasshopper, frog, snake, and then the hawk. We always start with the producer at the bottom of the energy pyramid and then move our way back up to the top of the pyramid, okay? And what is the whole point of an energy pyramid? It's just to show how much available energy there is for each trophic level. So this energy pyramid here shows the different trophic levels. Okay, the names primary producer, primary consumer, and so on. It shows the different organisms that are in each level. And then also here, it shows these numbers and it has kcal in it. Well, calories represents the unit that we use to measure how much energy is in our food. So kcal just means kilocalories. So it's a big amount of energy we're taking a look at. So which organism, looking at the energy pyramid, has the most energy? Well, if I take a look, okay, at the numbers, the grass has the most energy, has 10,000 kilocalories. That's the most compared to the other trophic levels. What about which organism has the least amount of energy? Well, if I take a look, whoever's at the top here, it's the hawk. It only has 1 kilocalorie of energy. And what happens to the amount of energy as you move up the energy pyramid? Well, if you see, okay, at the bottom of the energy pyramid, it has 10,000 kilocalories, and every time I move up a trophic level, the amount of energy decreases. So why does this happen? Okay, why does the amount of energy decrease as it goes from organism to organism or trophic level to trophic level? Now, remember, we said that only 10% of the energy that an organism gets from its food is stored in the body. The other 90% the organism uses up. Okay, so that's what we call the 10% rule. Only 10% is stored in the body, and then it's passed on to the next organism in the next trophic level. So let's take a look at the grass to the grasshopper. If we see the grass has 10,000 kilocalories, but only 10% of that 10,000 will be passed on to the grasshopper when it eats the grass. okay? Because the grass will use the rest of it, the 90%, to grow and to do whatever it needs to do during the day. So how do we calculate that number? Now I know that number is here, but how would you calculate it if the energy wasn't shown? Well, let's take a look. The grass has 10,000 kilocalories, and that's where I have 10,000 kilocalories. And then remember, only 10% of the grass's kilocalories can be passed on. So I converted that 10% into a decimal point number, and it turns out to be 0.10 or 0.1. And when I multiply these two numbers, I get 1,000 kilocalories, and that's how much energy the grasshopper can get by eating the grass. Okay, so the grasshopper can, when the grasshopper eats the grass, it only gets 1,000 kilocalories. Well, what about the next trophic level? So now we know that the grasshopper has 1,000 kilocalories. What about the frog? Okay, the frog will only get 10% of the 1,000 kilocalories that the grasshopper has. So how do we calculate it? Same thing. We take what the grasshopper has, 1,000 kilocalories, multiply it by 0.10, okay? And then here we have what's left over for the frog. So the frog can only get 100 kilocalories by eating the grasshopper. Okay. Well, what about the frog and it passing energy to the snake? Same thing. Okay, the 10% of the frog's energy can be only passed on. So 100 kilocalories times 10% will be only 10 kilocalories. So the snake can only get 10 kilocalories by eating that frog. And then the last one, same thing. How do we calculate how much the hawk would get? Okay, the snake can only pass on 10% of its energy, okay, 10 kilocalories, okay? So if we multiply 10 times 10% or 0.10, the hawk only gets 1 kilocalorie by eating that, that snake. So as you see, because only 10% is being passed on, that's not a lot of energy. So every time we move up the trophic level in a food chain, whoever's at the end, they get less and less energy. Whoever's at the bottom, which is always a producer, has the most energy. So go ahead and answer these two stop and drop questions. How much energy does the kingfisher get if the trout has 925 kilocalories? And how much energy does the algae have if the prawn has 9,250 kilocalories? So remember, okay, when we're taking a look, when we're going up the food chain, you're going, or up the energy pyramid, you're only passing on 10% of the energy. So how did we get 92.5 kilocalories? Well, if the trout has 925 kilocalories, only 10% can be passed on. So it would be 92.5. So what you're doing is, here's a little trick. If you move up the energy pyramid, always multiply by 0.10. Or you could actually move your decimal point place to the left. Okay, that's a little memory clue. Well, what about the next one? How much energy does the algae have? So if we don't know what the algae have, but we do know what's given is how much energy the prawn has, 9,250. How did we get that number for the algae? Well, in this case, we're going down the energy pyramid. So if you're going down the energy pyramid, the number should be bigger, not smaller, okay? So if that's the case, here we have 9,250 kilocalories that the prawn has. You can multiply it by 10, okay? And it should give you a bigger number, 92,500 kilocalories. So my memory clue here is, if you have to move down the energy pyramid and calculate the amount of energy, you can take what's given, whatever the number that's given, and multiply by 10. Or you can move the decimal point place to the right to make it a bigger number. So that's the energy pyramid. Let's take a look at the difference between a food chain and a food web. What's the difference between a food chain and a food web? Now, if you see the food chain that's on top, the algae points to the striped fish, which points to the spotted fish. The energy is only going in one direction, okay? And we only see one organism eating only one other thing. But in a food web, you can see more more food chains within this food web, and the food webs show energy flowing in lots of different directions. The thing about a food web is it shows all, most or all the organisms that are in that area and the variety of things that they eat and interact with. So I need you to go ahead and answer the Stop and Jot question. For each organism that's there, I want you to tell me, is it a producer, an herbivore, an omnivore, or a carnivore? Okay, so tell me all the producers, list down all the herbivores, all the omnivores, and all the carnivores. And then the next thing that I need you to do is name one food chain from the food web.